Hello, this is Ola speaking. The topic for this presentation is real-time and the second part of the introduction, and the subject is examples. We will go through some examples how to show that the maximum time will involve on our computer systems. Real-time is about time requirements, and the time requirements is very often about events from your process. You have some time requirement in the process, or it can be time requirements from external systems, or it can also be rules that is given to your system. So I will go through one industrial process and one process for data communication, or actually more specific, a specific protocol, communication protocol. And if you see here, telecommunication or protocols and control systems are two major parts of real-time systems. Our first example is a buffer tank. We have input and output. The input is a pump with a capacity of 1 liter per second. You cannot change the speed. A buffer system is very often a cheap solution. So here you just have an on-off pump with 1 second. The output can be anything between 0 and 1 liter per second. The maximum is 1 liter per second. And then you have two sensors indicating when it's full and when it's empty. Shall avoid it being empty or being full. So just look at it. The pump capacity is 1 liter per second. Buffer tank is 20 liter. You have sensors on 19.5 liter and half a liter. That means since it's 1 liter per second, you will have half a second to react from the sensor detecting high or low until the pump should be stopped. Pump is a mechanical rotating device, so you always have some sort of delay. In this case, we have a delay of 200 milliseconds from you send a signal to turn a pump on and off until it's stopped or started. You also have delay in the sensor connected to a DAC system and getting the information into a computer system. So if you're looking at up, when we're dealing with real-time system, we should always figure out the worst case and calculate the worst case scenario. So when loading, you will detect that it's full, then you have half a second. You have to take away 100 milliseconds for the sensor delay and 200 milliseconds delay for the pump. If you are discharging the tank, you have the same, half a liter, half a second, but you have a little shorter delay sensor, the same on a pump. But still, you should use the worst case, which is loading. So if you look at the time requirements for using a pump capacity of 1 liter per second, the worst case is 200 milliseconds. So your real-time system, based on an event from any sensor, you should be able to estimate or calculate or output a signal, the correct pump signal, within 200 milliseconds. What happens if the pump is broken and you need to buy a new one, and the only one that you can buy is a pump with a capacity of 2 liter per second? Can you use that one? 2 liter per second means that you have 250 milliseconds from you detect an either full or empty tank. And you see that you have 100 milliseconds and 200 milliseconds, so you need at least 300 milliseconds. So at 2 liter per second is not possible. Last one. What if you have a PLC with a cycle time of 150 milliseconds? Can you use that? Well, as you may remember, the maximum time of a PLC is 2 times the cycle time. So a PLC will use 300 milliseconds. So it's too long for this as well. Okay, next example is communication protocols. We have one protocol. It's based on a serial line. That means this node is going to receive a set of characters. And the normal way of doing that is to use an interrupt function. And in this case, we have calculated that the interrupt function will take between 10 and 25 nanoseconds. Baud rates, we have different baud rates here. And then the question is, do we have any time requirements? And of course we have. If our system is not handling each character, when we are or handling the receive of each character, we will lose character, we will lose information. So we have real-time requirements. 9600 bauds means that we receive 9600 bits per second, and that's about 960 characters. This asynchronous communication has a start bit and a stop bit and some parity bits in addition to the 8 data bit. So we're saying, to simplify it, 10 bits per character. So 9600 says 960 characters. So Yes, we have a time requirements, and then the question is how many protocols can we handle at 38,400 baud rate, or even at 15,000, which is the one that is used most on serial communications. So if you calculate it, a baud rate of 9,600 means 960 interrupts or 960 characters per second. And by using these interrupt function times, we can calculate that it's between 9.6 and 24 milliseconds. So the question was how many protocols at 38,400 baud rate. So that means 3,840 characters each second, and the maximum time for each character is 96 milliseconds. So in order to handle several protocols, the maximum number can be 10. 10 protocols, we will have 1000 milliseconds, which is 1 second, and that's what we can handle. But that requires that this node is doing nothing else than just receiving on 10 protocols. If we're running at 115,000, which is normal, which means 11,500 characters per second, means that you will use maximum 288 milliseconds for each line, and that means we can have maximum 3 protocols running in parallel on this node.